I started my career in Git by abusing Git. So the first thing in like 2005 or 2006 when I was a job before GitHub, we were using Git actually as a content distribution mechanism, right? So we had like all these sort of display machines, and we'd say these are the ads I want on it, and we'd create a different branch for each machine, and then we'd sort of have them all fetch, and it was a fantastic content distribution mechanism, and we used Perforce as our version control system. So I started by abusing Git, and I found it so interesting that I started writing about it and documenting it. And so some of you may have read, like the books that I've written and stuff on it. But a lot of it came from this is a really interesting thing. And so lately, I co-founded another company that's trying to do a new Git client, and we're trying to rethink a lot of sort of throwaway, how version control systems have sort of historically worked, and look at really interesting things like jujitsu, for example, and say like, what are some things we can pull into like a GUI? And so we're trying to do stuff that Git wasn't really designed for, but use Git as a backing because Git is an ecosystem, right? That you can push to lots of stuff. GitHub is an ecosystem. Being able to push to Heroku or whatever, like it's still a content distribution system. But like so how are we abusing it? I find it really funny to see that. What I did want to start with is I helped run the first GitMerge. So GitMerge actually came from get-togethers. Was anybody here ever at a get-together? Raise your hand. Oh, a good number of people. So Google Summer of Code used to bring everybody together on the Google campus, and then they would do this sort of Git sort of meeting of people who were interested in doing Git stuff in like 2010-ish or something like that, in that era. And they kind of stopped doing it, I think, and so GitHub, I wanted to keep doing this because I liked sitting around tables and hacking on Git stuff with people. And so GitHub did GitMerge. This was the first one here in Berlin in 2013, so it's been 11 years now. But actually, I can see Carlos, I can see Ed, I can see Michael. There's actually a bunch of the people that were in the first one that are still here, so it's a fun community. So I want to start out by just doing a quick, this isn't really like a, use GitButler thing. It's more what are we trying to do and why is that interesting from a Git perspective. But I do need to talk about what GitButler is. So GitButler is a GUI. I've never actually used a GUI in my life for Git. I always use the command line. And so the challenge is how do I make the things I want to do faster rather than having a button that wraps some command that I could just as easily run on the command line. So this is what we're trying to do. And one of the things, there's a bunch of interesting things that we're trying to accomplish, and we really have to abuse Git for some of that. And one of the things that we have is we have a thing called virtual branches. So in my mind, essentially the workflow that I would do a lot is say I'm working on a feature, and then I see a bug, and then the question is how do I deal with that, right? Like, do I stash everything I'm doing and fix the bug and commit it and push it up and kind of get it integrated and then go back and like unstash or switch branches or something like that? Do I commit the bug into the branch I'm doing, assuming that it'll be integrated with the branch? Do I, how do I kind of deal with orthogonal things that you're working on at the same time? And so what we're doing is we're doing this thing called virtual branches where you can have several branches that work out of one working directory, but you can sort of bookmark work and put them into different branches. So you can be on several branches at a time. And then I can take a branch where I've dragged a file change into it and then commit it and push it up to GitHub, and it's its own PR, it's its own branch as though it existed by itself, right? And so how do we do that? We do a couple of kind of interesting things. One is we assume that you have an upstream, right, which Git doesn't really care. There's no like origin master or origin main or something isn't special in Git. It is special in GitHub and in some of the forges where it's like, what's your default branch? But we try to have this in the tool itself. And so if you have origin main, you check out something in your working directory, and then you modify a couple of the files, but they are orthogonal, like those are different changes and you want them to go in different branches. Essentially what we do is we run the equivalent of git diff, actually in libgit2, I think generally, and we say, okay, for each hunk, what if I could assign that an ownership? So this hunk change is sort of owned by branch A, and this hunk change is owned by branch B, and we write that into a file. It's like a TOML file. And so we have this understanding of these changes belong to two different things. And so then when I commit them, I go and I can commit, and it will just take and essentially do like a patch apply. And so it'll just take the package.json and apply it to origin main as a patch. and commit there, and it'll do the same thing with tsconfig. But the nice thing, you can kind of do this with the index file, right? Like you can kind of patch stage some stuff and commit. But it's hard to go back and forth and kind of do this on multiple branches at the same time. So now if I say, hey, I'm going to change package.json again, and I commit, the ownership file gives our tool a hint, what branch does this logically belong to, right? Because it already has sort of an ownership of a range. And so if I edit it again, it's like, okay, well, when I commit, it commits to branch A and not branch B. And I can keep kind of going back and forth between these two things and working on several branches simultaneously. But the problem that came up is people use other tools. People use VS Code, right? People run Git status like on its own, and so we want Git status to say something. And Git doesn't have a concept of being on more than one branch at a time. I kind of have to choose one, right? For if you run Git status, how does it tell me what the difference between my working directory or my index and the last commit? Because I have two last commits in this particular case. And so what we do is we create like a work in progress commit that has status. And so we're constantly rewriting this. And it's not maybe unlike Jiu-Jitsu, right, which is kind of constantly rewriting a commit as sort of the head all of the time. We're doing this as well. Every time that you're changing something or doing a commit, essentially what it's doing is taking the heads of all of the branches that you have applied, merging them all together into sort of like one super commit. It actually does an octopus merge into this thing. Move GitButler workspace as, this is under refs heads, and say, okay, this is what the combination of all of your sort of last commits on your branches are, so that if it looks like this, by the way, and we put some information in here, here's where to find this ref in case you want to push just that branch individually off the command line or something like that. And we also exclude the decoration of anything under refs GitButler so that we're not messing with your refs head space. Like we kind of want to not screw with your Git stuff as much as possible, right? If you want to switch away from us or something like that. But if you edit a file in the working directory now and you run, git status, or if you run git diff, or if VS Code is asking what the status is, it can tell you this is what has changed, but it works across all of your branches, right? And so that's kind of like an interesting thing that we're trying to do of saying, how can you, with Git only thinking that there's one branch that exists, say, okay, I'm on 5 branches, but like, how do I make my tooling make sense? Another interesting thing that we do is a timeline. So this was inspired to a large degree by the Jiu-Jitsu op log, and it does a very similar thing, right? So if you click this little button in the corner on GitButler, everything that you do all the time in a Jiu-Jitsu manner is being recorded. So before you do anything, like if you click on anything and say, update my base branch or commit something or whatever, it takes sort of a pre-snapshot of what did everything look like before that, and it stores it so that you have this nice timeline and you can hover over any of these and hit revert, and it does what Jiu-Jitsu did, right? It reverts to what it looked like right before you did that thing, right? So if you mess up something and everything's in a conflicted state or you don't like where you are, you can just go back and just say, go back to before I did that, and it'll revert to before that point. But how do we do that? So we keep all of this data in Git as well, right? And we keep it, I actually don't know how Jiu-Jitsu does this, but we keep the state of everything that we know about in a different Git timeline that has no ancestor to your actual project timeline, right? So it has a lot of the same files, it has a lot of the same objects, right? Because it's storing like the state of your working directory and stuff, and a lot of that is the same as you'll be keeping in your project. But we keep it in a separate thing. And so we don't keep that head, we don't keep it in refs heads something, because if you run git log -- all, it's gonna really screw up, right? It's like GH pages or wikis or anything that tries to like be like a different system within Git that is not your project. It sucks to do log operations sometimes because it's like, well, this is a completely different thing, right? Why are you keeping two like unrelated histories in one repository? So we keep it in this TOML file, and it looks something like this, right? So we have some headers, and you can see each one of these sort of commits like maps to one of these things in the project history. And when you say revert, we know kind of what the state of everything was before that, right? So this is how we keep this data. And if you look at it, if you actually cat file the commit that you look in that TOML file, we have sort of, this is the state of your project at this point before we ran this thing, which is kind of cool. So we build this up in memory in libgit2 and write it and say, okay, this is what everything looked like right before you ran the operation, so we can get back to that point if you need to. And if you look in the virtual branches tree, for example, underneath that, we have what's the state of your workspace, what are the state of your two virtual branches that you're on at that point, and so we can put all that back, which is cool. The problem with something like this, like I said, is that because it's not in refs heads, if you run Git GC, it will just fucking delete shit, right? Like it'll just go through and be like, I can't see a lot of these trees or a lot of these commits or objects or whatever, and GC after several weeks will say this is an unreachable object and it'll prune it. And this is a common problem with anything like like GitHub Pages or something that tries to keep this data alongside your project data. So what can we do, right? We can add a ref, but again, git log -- all is going to look stupid. We can, git log -- all. So what else can we do? And I tried to come up with something clever to do, and what we did is we hide it in the ref log. So GC sees the ref log and will see any entry in the ref log as reachable. And so what we do is we write out this actual head, which is refs heads GitButler target, which says this is the base of kind of what all of your branches are based off of, which is a little bit different than like origin main, which could have moved forward, right? This is all of the branches, all your virtual branches are based off of this as a base, and you can update that. And so we have this thing, which kind of makes sense to see when you run git log. You want to see kind of what are all my branches based off of, but we don't actually allow you to keep the ref log. So every time that you do anything that adds to the timeline, we overwrite this. So it always has 2 lines. And the first line is the actual history of GitButler target, right? So it kind of makes sense. So if you actually look at that, the first log in the ref log, first line in the ref log, it'll say, okay, here's where origin main is or whatever, or was when you created your branches. The second one, though, is the tip of your operations log, right? And so the nice part about this is that anything we put in there does not get GC'd, but we also don't need to have any of the parcel and stuff see that it exists. So that's kind of fun. If any of you are trying to do like some wiki, that's like alongside your Git repository and you want to keep it there and be able to push it, separately or something like that, this is kind of a fun workaround in how to get to not GC stuff. And this is common, right? There's all sorts of stuff. I did a ticketing system called Ticket like years and years ago, and I dealt with this same problem. GitHub, I helped implement the GH Pages stuff, and this was constantly a problem with why do we have these stupid heads around. And actually, I think Microsoft hit this with the prefetch headers as well at some point, where they were trying to not sort of decorate the prefetch headers or have some hidden namespace or something like that. Anyways. The other thing we do, also similar to Jiu-Jitsu, is we have a change ID so that as we're rebasing stuff, we remember what we were rebasing or what if you change the commit message or something like that. Actually, there's a lot of stuff in Git that looks for patch IDs or tries to match on commit message. If you do like a fix-up commit and do an auto squash or something like that, it's a little janky on how to do this. We don't want to deal with any of that, so every time that you do a commit, we inject a change ID. And so again, you can see this in tools like Jiu-Jitsu. I think this is most people think this is a relatively good idea to do, where these do not change, but as you're doing rebases, the actual sort of the commit SHA does change, right? It has to change as you're rebasing stuff. But you'll see it in very common Git tools as well, right? Like this is a valuable sort of thing to have. And so in Garrett, obviously, if anybody's used Garrett, you have to use special tooling because it has to inject a change ID so that the sort of commit flow can work with this. For us, though, I don't like the Garrett thing because I don't like seeing it in the trailer. Like I don't like running git log and seeing that there or seeing it on GitHub or something like that. And so we're hiding it in the commit header. Which I don't know if anybody has any please don't do that type feelings. I think some of you may. I kind of did at first, but I did extensive testing. So this is actually what it looks like, right? If you run git log on a commit that the GitButler created, it looks normal. If you actually if you cat file, we inject a new header into the commit object, right? And so I can pull it out programmatically. I can pull it out with libgit too. But nobody has to actually see it, right? It's kind of this nice hidden metadata. And I was like, is this gonna break stuff? Is Gitfist gonna complain? Like, is GitHub gonna break? Like, what happens? And it turns out, actually, nothing cares. Actually, Pef was explaining to me that the reason why is probably because the Git developers always assume there might be more headers introduced at some point, and so most of the tooling is fine with stuff that it doesn't recognize for future backward compatibility reasons. But none of the libraries can inject a header, right? It is not something that is okay to do generally. The only way you can actually inject a header in Git is to run. This is the only in libgit 2 at least is to you have to in order to do a signature, right? So to do a GPG signature or SSH signature, you have to create what it would look like without the signature, and then sign it, and then inject the signature into the middle of the commit header, right? At the end of the commit header. But the way that you do that in libgit 2 is you say create the buffer of kind of what I would write to the ODB, and then I'm going to sign that somehow else, and then create with signature. You can actually put anything as this signature field and anything as the signature data. So I could write an arbitrary header that way. It actually it's not specific to signatures, but you can only do it once because that actually writes to the ODB. So you can't get a buffer back and do it a second time, right? And so there's actually no way in libgit 2 to do this. And so what we end up doing in Rust, this is a Rust project, is we do the same thing. We create the commit buffer. We have our own sort of, set the GitButler headers, and we put in whatever headers that we want the same way that the signature does. We can optionally sign it at that point. If you put the thing, then we sign it, right? And we'll inject the signature header at the end. And then we just do an ODB write from that buffer, right? So we actually don't have we're just directly saying, here's a thing, and it's a commit object type, write it into the ODB. And it, fuck it, it works fine. So the question is, what breaks, right? I actually, there are a handful of things that break. Oops, I don't have a slide for that. There are a handful of things that break. There are a couple things that assume that you don't have any headers, and it will rewrite stuff, and then the SHAs don't match. Most stuff won't blow up, though. So JGit doesn't blow up. CGit, like the canonical Git, will not blow up. libgit 2 won't blow up. GitHub will strip them when you rebase, when you do a rebase merge of a PR. It will take out any headers that aren't canonical. I'm actually curious if that works for like encoding headers and things like that. I haven't tried it with a bunch of other headers. It's a little bit difficult to figure out how to test this, but as far as I can tell, if you want to inject like random headers into your shit, go ahead and do it, because most things don't care. So kind of fun. And then the last thing I want to talk about is deferred conflict. So this is, again, a thing that we kind of stole from Jiu-Jitsu, where I thought this was really interesting, of saying, if I do a rebase, and I have 5 commits that I'm rebasing, and one of them has a problem, in Git, it would stop, and then you have to either abort or continue, and you have to get through the whole thing in order for the rebase to happen at all. What Jiu-Jitsu does is say, that one doesn't work, so I'm just not going to apply it, and then I'll try to apply all the other ones, and I'll keep doing it, right? And so if I can apply 4 out of 5, that's a better starting point, and I can even continue working and then go back and fix it at some point, and it'll rebase off of that, right? And so we do the same, or we're working on the same thing. I don't think it's in the general release yet, but we've been working on it for a while. So if I have one branch where I've changed one file twice, and I have another branch where I've changed a file once and then another file again, and then origin main updates, right? So, and it updates in a way that will conflict. Then what I want to do is I want to rebase my branches on top of that. And so if I do that, then what I get is a conflicted state, right? So this one's fine, nothing was conflicted. This one has one of the commits in a conflicted state. But what we do is we just say, okay, I can apply this, so just don't change tsconfig. Just use it, just remain kind of what it was in origin main. Don't just try to apply that patch, just apply whatever parts of the patch I can. So the README does change, but the tsconfig remains how it is in origin main in this case, right? And I say, this is a conflicted commit. You're going to have to go and fix this at some point. I won't let you push until you fix this thing. And so what you do is you click on it, you check it out, you fix the thing, you commit it, and then it rebases the rest of stuff on branch B. So now I'm on V4, and then the README still moves over, but now branch B has V4. So I like this idea. I like the thing of being like, whatever works, do it. Whatever doesn't work, mark it, but keep going. And there's a Unconf talk tomorrow about kind of how we're doing this and how Jiu-Jitsu does this. And I find it a really nice way of being like, okay, I'll deal with it when I want to deal with it. And so this is kind of what it looks like in ours, is you say, okay, these are coming in from upstream. It marks them as conflicted. You hit resolve conflicts. It puts your working directory into that state, right? So now you have your diff3 markers. We just use diff3. But if you look at it, all we've done is we've injected this GitButler conflicted header so that our tool knows this is a conflicted commit. But what's also kind of interesting is what the actual commit tree looks like. So the commit tree no longer points to the tree of the project. It doesn't look like the project anymore. We stole this entirely from Jiu-Jitsu, basically. So they do the exact same thing. If you look at their Git data, this is how they do conflicted commits, is they have conflict base, conflict side 0 and 1, so that I can recreate it when I want to, right? What we do that's a little bit different, I think, we put in a conflict file so that I don't have to recalculate this every time. I could just show it in the GUI, say these are the 5 files that are conflicted. And then we have an auto resolution. So this is essentially the output of a GitMerge --rs strategy. So we don't not apply the patch at all. We just apply all the parts of the patch that don't conflict, and then everything that does conflict, we use the R strategy to say, just use whatever the base was, not whatever I'm trying to rebase onto. And then we do the rest of the rebases off of that tree, which means that more of them tend to work, right? Because if there's something that was modified here that then a later patch changes, like at least we might have it, right? So, which is kind of cool. So that's pretty much my talk. To sum up, I love change IDs. I think it actually would be interesting to talk in sort of a core team sort of Git thing of should Git support change IDs, right? We're already commuting the author data all the time. Every time we do rebases, it'd be kind of nice to have a UUID in there where it's like, this is this patch, right? Like every time I'm rebasing it, I don't have to kind of guess or do these weird heuristics to do that. I actually think it'd be nice to support arbitrary commit headers and to have APIs for this, because I think there's lots of places where this could be nicer than trying to put it in as an ugly trailer on stuff. But that's kind of, that's more anything you do with arbitrary commit headers you can do with trailers. It's just I don't like the way trailers look, right? Like, so it's really kind of a thing. But yeah, again, libgit2 and core git, like, do not make this easy to do. It's quite difficult to inject headers, but also neither of them care if you do it, which is interesting to know. And then I would actually, my last thing, I would really love to have some way for core git and the libraries to have, or mostly core git, because it's mostly a UI issue, to support hidden refs, right? So Git has namespaces, there's Git namespaces, but that only really apply, it does this thing, right? It says, just pretend like these are the only refs that I have right now, right? And you can have completely different things, but that only works on the server stuff, right? So as far as I can tell, I've tried as hard as I could to get this to work on client stuff. It doesn't seem to do it. Anything in refs if you do git log -- all, it will show everything in refs, right? But I think it'd be really nice to say, like, just ignore these as though they didn't exist for most of the porcelain stuff, but I can still keep them there, they're tracked, and I can push and pull them if I need to. So that's it. Thank you very much.